Hi everyone. Today we're solving systems of linear equations with the substitution method. Okay, so let's just jump right in. We have a system here, y equals 6x minus 11 and negative 2x minus 3y equals negative 7. Okay. When we're solving with the substitution method, the first thing that we want to do is to take one of the equations and solve it to the point where we have one variable by itself. Okay. In this case, we already have one variable by itself. If we look at our first equation, y equals 6x minus 11, that already has y by itself. So we're good with that. We don't have to do anything else on this step. The next step is that we're going to substitute and solve. So we're going to start with this negative 2x minus 3. And you notice we're going to the second equation here. However, instead of y, I'm going to substitute in this whole 6x minus 11. This is equivalent to y. So with substitution method, really what we're doing is we're substituting an equivalent expression for one of the variables. And that way we get it so that we have an equation that only has one variable in it. Okay. In this case, our equation now only has x's in there. All the y's have been replaced. Okay. So substitution method, we're replacing one variable with an expression of equal value. So now we need to solve this equation. And we're going to start by taking this negative 3 that's right here, and we are going to distribute that into the parentheses. Okay, so negative 2x, negative 3 times 6x gives us a negative 18x. Negative 3 times negative 11 gives us a positive 33, and then equals negative 7. Okay, and then we have some like terms here. We could take these two like terms and add them together. So negative 2x minus 18x is going to give us a negative 20x. And then we're just going to bring everything else down. So plus 33 equals negative 7. And then now we have it down into a two-step equation. We've simplified everything and we can just start solving. So I'm going to subtract 33 from both sides. And let me erase one of those. Okay, minus 33. So we're going to cancel it on the left side. We're left with negative 20x equals negative 40. And then we're going to divide by negative 20 because we want to get x by itself. Ultimately, we're going to be solving for both x and y, but right now we just need to solve for x. So this gives us a 1x, and negative 40 divided by negative 20 gives us a positive 2. Okay, so now we have one of our variables. Okay, I could go back to this original equation that we used to get a single variable, okay, that y equals 6x minus 11. And I'm going to do y equals 6. Only this time, instead of x, I'm going to put a 2. So 6 times 2 minus 11. Hold on, let me fix, there we go, minus 11. All right. And we're just going to go ahead and multiply this together. So 6 times 2 is 12. And 12 minus 11 is 1. So our y equals 1. We now have both the x and the y for our system here. And so we can put it together as a point where, these two lines, these two linear equations cross at the point 2, 1. That's our solution. Okay. So now let's look at another example. On this example, we will have to actually rearrange one of the equations to solve for a single variable. It doesn't matter which equation you use, and it doesn't matter which variable you solve for. You always want to look for which one's going to be the easiest to rearrange and which variable is going to be the easiest to get by itself. Okay, so if I look at these two equations, negative 7x minus 2y equals 13. None of those numbers are multiples of each other or factors of each other if we go the other way. So that's not going to be very easy. I can get either x or y by itself, but I'm going to end up with fractions. And I really don't want to end up with fractions. They're a little harder to work with. On our second equation, we have x minus 2y equals 11. Well, now that one's going to be really easy to get one of my variables by itself. As a matter of fact, with this one, all I have to do is add 2y to both sides of my equation. And I have x all by itself on one side. So 2y plus 11. X equals 2y plus 11. There we go. So now that I have one of my equations solved to get one variable by itself, now I'm going to substitute that equivalent expression into the other equation. So I'm going to take my negative 7, and instead of putting an x, I'm going to put 2y plus 11. 2y plus 11. And I'm going to finish out my equation there. So minus 2y equals negative 13. Once again, I'm going to simplify that left side. I'm going to distribute that negative 7 and then combine any like terms I have. So negative 7 times 2y is negative 14y. Negative 7 times 11 is negative 77. And then we have our negative 2y equals negative 13. Okay. And I've got like terms here with my negative 14y and my negative 2y. So I'm going to put those together. So negative 14y minus 2y is going to give me a negative 16y. Minus 77 equals negative 13. We're just bringing everything else down until we get ready to actually use it. All right. It is time to add 77 to both sides of my equation because now I need to actually start solving. Okay, so we're going to cancel that out there. Negative 16y equals 64. We have a positive and a negative, so we subtract them, keep the sign of the larger number. And then we're going to divide by negative 16. So y equals negative 4. Okay. So now I have my y, I need to find my x. So I'm going to go back to my original x minus 2y equals 11 equation. And I'm going to say x minus 2. And instead of y, I'm going to put in negative 4. So times negative 4 equals 11. And I'm going to simplify this left side and then solve. So negative 2 times negative 4 gives me a positive 8. And when I subtract 8 from both sides, I get x equals 3. So then the common point where these two linear equations cross each other is at 3, negative 4. Okay. No matter which order you solve to get your variables in, your answer is always going to have the x first. It's always going to be x, then y. Okay. Now, anytime we're solving equations of any sort, Anytime we're solving equations where we've got multiple variables or maybe variables on both sides of the equation, there's always a possibility to have a special case. All right, so now let's look at a couple of special cases. I have negative 3x plus 3y equals 4, and I have negative x plus y equals 3. So it's probably going to be easier just to get that y by itself, because then if I try to get the negative x by itself, then I have to divide by negative 1 to make x positive. If I try to change the red equation, 3 and 4 are not factors or multiples of each other, so we end up with fractions. So the blue equation is the one that is going to be the easiest to rearrange. Okay, so I'm actually going to add x to both sides. Okay, so that's going to cancel out. We're going to have y equals x plus 3. That's my equivalent expression for y. So I'm going to go to my red equation now. Negative 3x plus 3. And instead of y, I'm putting in x plus 3. So x plus 3 equals 4. Okay. So I'm going to distribute this 3 in there. We're going to simplify that left side. So negative 3x plus 3x plus 9 equals 4. Okay. And if we look, negative 3x plus 3x, those are my like terms. But when I add negative 3x plus 3x, I end up getting 0. These cancel each other out. Okay. So 9 equals 4. Well, now that's not true. Okay. 9 does not equal 4. 9 is actually bigger than 4. So because this is a false statement, I can't do anything. All my are gone. I don't have any variables left. All I have is this false statement that 9 equals 4. So this is actually a no solution. And if we were to actually graph these two equations, we would find out that they're actually parallel lines. Okay. These two lines would actually run like this on each other, and they would never cross. So there's no solution. Okay. We can even make a note of that and say that they are parallel lines. Okay. So because it was false, we don't have to do anything about finding the other value and writing our solution. Our solution is that there is no solution. Okay. And our last example is we have 2x plus 8y equals 6 and negative x minus 4y equals negative 3. Once again, we just need to try and figure out which equation is going to be the easiest one to rearrange to get one of the variables by itself. If we did the red equation, we have 2x. The 2 goes into both the 8 and the 6, so we could easily move the y across and then divide by 2. If we did the blue equation, 4 and 3 are not factors of each other or multiples of each other, so it would be easiest for us to solve for x. And we would just need to move the y across and then divide by negative 1. I like that option better. It's a little bit easier. There's not a lot of dividing that we have to worry about. Because when we divide by a negative, really, we're just changing signs. So we're going to do that one. We're going to take this negative x minus 4y equals negative 3. And we're going to divide, we're going to get the x by itself. We're going to rearrange to get x alone. So we're going to add 4y to both sides. That cancels out. So we have negative x equals 4y minus 3. Then we're going to divide everything by negative 1. And you're going to notice that once we divide by negative 1, all it's doing is changing the signs for each of our terms. Okay. Our negatives became positive, our positive became negative, and that we're good. All right. So now we have an equivalent expression equal to x. Okay. We're going to take our 2x plus 8y equals 6 equation. So 2. And instead of the x, we're going to put in this negative 4y plus 3. So negative 4y plus 3 minus 4y, sorry, wrong equation, plus 8y equals 6. All right, sorry about that. Okay, so now we're going to distribute the 2. We get negative 8y plus 6 plus 8y equals 6. Once again, we're going to combine our like terms so we could simplify this left side. So I have negative 8y plus 8y, and those are actually going to cancel each other out. They're a 0 pair, so negative 8y plus 8y is going to be 0. And we're left with 6 equals 6. Once again, all of our variables are gone. However, this time, the equation that we're left with is actually true. 6 does equal 6. Because this is true, then we have an infinite solutions. Okay. This is a special case where we have infinite solutions. Really what this means is that the two equations that we have are actually just the same equation. It's one equation that's been multiplied by some value to make it look different. Okay, so essentially, if I were to graph this, then my first line would kind of look like this, and my second line would go right over it because it would be the same line. Okay, that's our infinite solutions. Okay, so you could actually just say infinite solutions, it is the same line. Okay, thank you guys for watching this, and if you have any questions, please put them down in the chat. I'll be happy to try and answer them for you. Okay. Thank you guys. Have a great evening, and we'll talk to you later.